Hello Year 9, today we are using tree diagrams. This is another way of showing the sample space for an experiment. So there's a little sentence here at the beginning for us to read. It says, tree diagrams are used to display the sample space for experiments with 2 or more steps. So we have the arrays that we can use if there's only 2 steps. But if there's 3 steps or 4 steps, then we can't really use those tables anymore. So the tree diagram is another method that we can use for helping us to list off a sample space that has more than 2 steps in it. So let's have a look at the examples. Example number 1, 2 coins are tossed. We did this question with the array last lesson. So using a tree diagram to do it. It says complete the tree diagram to show all possible outcomes. So the 2 steps in your experiment is the first time that you toss the coin. So the first time that you toss the coin, you can get a head or a tail. So you list the possibilities underneath each other like this, and you have these branches. That's why it's called a tree. You have these branches coming out. So the first toss, I could get a head or a tail. Then the second set of branches is for the second toss. So the second time we toss a coin, we could get a head or a tail from the first outcome, or a head or a tail. So each outcome needs to be split into a head or a tail again. Okay, and so that is the tree diagram drawn up. To list the outcomes over here, we go along the branches. So the first branch going up across the top here is head, then another head. So the first outcome is head, head. Then, that was this one here. The second branch would be head coming down to the tail. So head, tail. Then we would need to come down to tail, head to read this branch. And then the last branch would be tail, then tail. Okay, so it's the same 4 outcomes we had last time. It was just a different way of presenting them. So part B says, what is the total number of outcomes? These things that I've written here in blue, there was 4 different outcomes. Part C, find the probability of tossing 2 tails. So 2 tails was this option down here at the bottom. So of the 4 options, there's only one of them that has 2 tails. So that means a probability of 1 out of the 4. Part 2 says find the probability of getting 1 tail. So that would be this one or this one. Both of those have exactly 1 tail. So that's 2 options out of 4, which simplifies to a half. Part 3 says no tails. So no tails would have to be this one up the top, which is head, head. It's the only one that has no tails in it. So that's 1 option out of the 4. And part 4, at least 1 tail, means it could have these 2 that have 1 tail, or I could have 2 tails. So that means 3 out of the 4 options. Okay, on the next page. Andrew, who we're going to call the letter A, Bruce is B, Chris is C, and David are D. They are 4 friends who enter a competition. They win 2 free tickets to a mathematics lecture. Ooh, lucky them. And are all very excited about the thought of attending. Draw a tree diagram to show all the different ways that two of them could attend. So they have 2 tickets. So first of all, they need to decide who's going to get the first ticket. So that's going to be my first outcome. So first ticket. Now there's 4 of them. So Andrew, A for Andrew, B for Bruce, C for Chris, and D for David. One of those 4 would need to be picked to get the first ticket. So that is my first set of branches. Then they're going to have a second ticket. Okay, so in the second ticket, if Andrew already has a ticket, he doesn't need the second ticket, does he? So there's only 3 people that I would choose from the second ticket for that. I would choose B, C, or D. Andrew doesn't need another ticket. Okay, then if Bruce gets the first ticket, he doesn't need the second ticket for this one. So that means we would have A, C, or D for the second ticket there. And then if Chris gets the first ticket, it means that A, B, or D will want the second ticket. And if D, which is David, gets the first ticket, then A, B, or C could get the second ticket. Okay, take a second to think about that. I hope that that makes sense. Then it says, what are the total number of outcomes? Now, we haven't listed the outcomes out the side. Let's do that. So as we go along each branch, it could be A, then B, A, then C, A, then D. Then the next one for B, if Bruce gets the first ticket, it'll be B, A, B, C, B, D. If Chris gets the first ticket, C, A, C, B, C, D. And if David gets the first ticket, D, A, D, B, D, C. So if I count down that list, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 different ways, 12 different outcomes for them to select who out of the 4 of them, which 2 of them get to go to this very exciting maths lecture. Part C, find the probability that the 2 friends who go on the lecture include Andrew and Bruce. Now, it just has to include Andrew and Bruce, but it doesn't really matter if Andrew gets the first ticket or the second ticket. So it could be Andrew, Bruce, or it could be Bruce and Andrew. Either way, they both get to go, right? So that means that there is 2 ways out of, remember that there's 12 outcomes there, 2 out of 12 ways that Andrew and Bruce are the ones that get to go. So we can simplify that. 2 out of 12 is 1/6. Part 2 says that Chris and David get to go. So that's C and D. So we could have C and D or D and C. So that would also be 2 out of 12, which again would simplify to 1 out of 6. What is the probability that Andrew gets to go? So it doesn't matter who he goes with, but Andrew gets to go in this one, this one, this one, this one, all the ones that have an A in them. That one and that one. So 1, 2, 3, 4, 5, 6 options out of the 12 that Andrew gets to go, which will simplify to a half. But I'm typing that in here for you. 6 over 12 is a half. And the part 4 says, what is the probability that Bruce or David gets to go? So we want to tick any one of those that has a B or a D. So that one has a B, that one has a D. Those ones all have Bs. That one has B and D. B, D, and all Ds down there. Okay, so all of those ones would have either Bruce or David or both of them attending. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of the 12, which simplifies to 5 over 6. Okay, and then here is some questions down here for you to try, your probability trees.